Alrighty guys, 7.1.3, which multiplier should I use? Hopefully this is big enough for you. If anything, go full screen, and then the question should pop up either on the side or on the bottom. So as you've seen many times in this course, there's usually more than one way to solve a problem. When a problem uses portions, so fractions, decimals, or percents, remember there's multiple ways, there are different ways to write the numbers and different solving strategies to choose from. We're going to look at different multipliers that can scale a quantity and see which one of them will help you find it. So as we work by ourselves on the computer today, consider the questions below. What multiplier or which scale factor should I use? And then how can I write an equation? All right. 727, Hugo and his family were shopping and purchased a new bed. The bed was a great deal at 60% off the original cost. The bed was originally $245. That is pretty good for a bed. So draw a diagram for the situation. What they mean by a diagram is, I mean, you could draw a bed if you want. But what we're looking at is this line diagram. So here is, remember our percents go on the bottom. Well, so this is 100%. That's the whole thing. This would be $245 is the whole thing. So give me a guess real quick before you calculate anything. How much do you think it would cost if it was 60% off, right? So keyword off. You're not paying 60%. It is 60% off. Okay, so we look at this, 60%. If this is like half, this is 50%. I'm going to go ahead and say this is 60%, right? Which means this part, 60% off. Okay, so if 60% off, right? If you're not paying 60%, what percent are you paying? Right? So if you're not paying 60%, you are paying the rest, which is 40% you pay. Right? Okay, if he scales or multiplies the original price by 60%, what will be his result? So this is our diagram. This is A. B, if he multiplies it by 60%, so this is 60% times $245 is the original price. Okay, remember, multiple ways that you can do this. You can multiply it as a percent. So here's my percent button right here. You could do 60%. We can do it as a fraction. So fractions, percents are always over what number? Over 100 times 245. Or the way my brain works, usually I just do the decimal, right? So 60 hundredths would be 60 hundredths or 6/10. All of these should give you the same answer. That was terrible. Okay, all of these should give you the same answer. Right, so let's do this. 60%, so 60, if I change that to a percent, it'll give me that decimal if I hit that percent button. Right, times 245. This will give us $147. Okay, what should Hugo multiply the original? So this is what the result is. This is a 60% off. This is $147 off. Okay, what should Hugo multiply the original price to find the new price of the bed? Okay, so whenever I go shopping, if I see 60% off, I don't ever use 60% as my multiplier, right? Because I'm trying to look at what I'm going to pay for. You are paying 40%, which means I'm going to multiply it by 40%. So 40% of 245 is what you pay. Because when we buy things, we're not really interested in how much, I mean, a lot of us would be interested in how much we're saving, but really what you're looking for is how much are you actually going to pay for this, right? Because you could be saving $1,000, but if you're still paying a bunch of money, then it might not be worth it for you, right? So 40%, hit the percent button, times 245. So let's do it like this. 40 over 100. Percents are always over 100. We have 40 hundredths times 245. This will all give you the same answer. And this will give you $98 you pay. Okay, key thing we want to look at right here, $147 off, $98 you pay. If we add these together, 147 plus 98, this will give me a total of 245. That was my 100%. right? So if I look back right here, this 60% on my diagram, this is going to be $147. This part right here is going to be $98. Now, $98 for a bed, I would make sure that you test it out to make sure that that's the bed that you want, right? Because a lot of times, price and quality go hand in hand. Okay, find the sale price of the bed in two different ways. That is using two different multipliers, okay? So we did that, right? We used 40% as a multiplier. We used 60% as a multiplier. What do you do with this one? All you have to do is take 245, you take off 147, and this will give you the $98 that you pay. Okay, how do your answers or your two methods compare? They're the same thing. If you look at it, using the percent off, that will give you one extra step to figure out what you want to pay. But I mean, I have been using this method for years, right? And it took me a while to figure out that I could just do 40% of what I pay. Okay? Next one. Hugo's older sister, Sandra, had the same summer job for the past 2 years. Last year, she worked an entire summer and was paid a salary of $3,000. This summer, she's going to get a 6% raise. To figure out how much she makes, Sandra drew the following diagram. So this is a diagram, and now we're extending because, go ahead and draw this diagram in your notebook. Here is the 100%, right? Here would be adding 6%. So 100 and add 6%, we're looking at 106%. Okay. Oh, copy that on a diagram. Perfect. Here, I'll do it with you. Hey. 100% would be last summer. Right? Then we extend it because she's getting a raise. This is totally not drawn to scale, by the way. 6%. So this total, this new total would be 106%. Okay, since Sandra's salary is increasing, does it make sense for her scale factor that it should be less than 1, equal to 1, or more than 1? And then why? So pick one. All right, so B, this is greater than 1, right? Because 1 would be the 100%, right? She's getting a raise. It's got to be more. She's going to be making more money. And then when you figure out your answer, if you get something that's less than $3,000, which is what she had made, then you need to redo your math, right? Because she's getting a raise. And that's why these word problems are good for us, is because it gives us context and we can make a reasonable answer or guess. Okay, diagram shows Sandra's original salary and the amount of the increase. What is the scale factor between her original salary and her new salary? That is, what number could she multiply the original salary by to get the new salary? We did this already, right? She is not getting 100%. She's getting 100%, which is her original. And she's getting a 6%, which is her raise, which will give you 106% is the multiplier. Right? So just like, just like the previous one where it's getting cheaper, you are paying less than 100%, right? Here, we're getting a raise. It's going to get more, I mean, not expensive, but you're going to get more money, so it's going to be more than 100%, okay? Show 2 ways the different scale factors Sandra can use to compute her salary. So we're going to do the same thing for D, right? First, we can find her raise, 6% times 3,000, which is how much she made. Remember, that's in the problem right here. So if I take 6%, so 6% would be 6 over 100, which would be 0.006. All times 3,000 will all give you the same answer, right? So 0.06, 600ths times 3,000 would be a $180 raise. So that's her raise. And so plus the $3,000 would give you $3,180. Let's see if the other way we can do it too. Right? So instead of 6%, we're going to take that shortcut. So in cutting this off, that's your 100%. 106% or 106 over 100 or 1.06 all times 3,000. 1 600 times 3,000 will give you the same answer. Okay. $7.29. Marana teaches gymnastic lessons at summer camp. She is paid $12.50 an hour, right? So if she was offered a 100% raise per hour, right? Think about how much she would be making then. Right? She's pretty much doubling it. So what would her new hourly rate be? Right? So she original, I could put $7.29, was $12.50. She's getting a raise of 100%, meaning she is making all of this again, which is $12.50. What is this total going to be? How much is she going to make now? $25 per hour. That is awesome. I wish I could double my salary. Okay, what percent of her original pay would she be paid? Percent, right? So she's getting paid. Original was 100%. We're adding the 100% raise, so it will be 200% of her original. Double it, right? Okay. She is offered a 75% raise of her hourly rate to teach a private lesson. So how much per hour would she be paid for her private lesson, right? So remember, we're taking the original, which is $12.50, and we're adding a 75% raise, which we have to figure out, right? So two ways you could do this. You could take 75% of the $12.50, or my original was 100, so I could take 175% times $12.50. 175 times $12.50. This will give us this number. No, it's money, right? So we round. $21.88. What percent of the original pay would she get? That's this, right? Percent of the original pay. C, what is the relationship between the percent raise that Marana gets and her new pay as a percent of her original pay? Relationship between the percent raise and the percent, her new pay, right? So how is this related? So we take original pay is 100%. New pay is a different percent, right? Depending on the situation. What do we do to find it? You add them together. So let's review, right? If you're getting a raise, or if it's going to be more expensive, or if whatever the word problem is, you know that your number is going to be more, you're going to take your 100% and add whatever percent that is, right? So 75% raise, add the 75%. A 75% markup, right? You're making something more expensive. If you're a business, then you add the 75%. If it's going to be less, oh, this includes like taxes, right? So if you have a 10% tax, then you add that 10%, right? Anything that will be increased. On this side, this one, when you have a discount, a sale, a markdown, these are all words that tell you it's going to be less. So you're starting with that original, the 100%, and then you're subtracting whatever percent it is, right? 60% off, 60% sale, 60% marked down. You're going to subtract that to find the original, right? And you can do whichever method you want, whichever one's easier for you. Okay, last one. So Liam was working on the problem and drew a diagram like the one below. He then wrote the equation, 72 times 1400ths equals x, right? Does his equation agree with this diagram. If you agree, then solve for his equation. If you disagree, then write and solve in a new equation that will find x in his diagram. So first, do you agree or do you disagree? Okay, 14 hundredths right here, because this is the equation right here, that is just for this section, the 14%. This is not accurate, right? So you should have disagreed. If we wanted to find x, we would have to find what percent this is, right? Because it's all keeping it, the ratios, keeping it the same, right? To find this percent, I have 100 minus the 14, right? This will give me 86%. Now, when I want to know 86% of 72, because that is the one that matches the percent with x. 86% of 72, 86% times 72, 86 over 100 times 72. And of course, we would simplify. And then 86 hundredths times 72. Right? Again, if we don't remember, percents are alls out of 100. This is just how you say it, 86 hundredths, right? Or even if this fraction bar, what operation is this fraction bar? This is division, so 86 divided by 100, that gives us 0.86. Okay, so multiple ways that you can solve it. The other way you can do this is if you did this equation, that would find that number right there, and then just subtract it from 72. Either way works, right? Multiple methods, whichever one makes sense to you. Okay, if you have questions, feel free to email us. We're going to do office hours